Welcome to a bold vision of the future, where humans venture beyond Earth and make Mars their second home. In this journey, we'll explore the exciting concept of making the red planet habitable for human colonization. As we look up at the stars, we realize the incredible potential that lies beyond our home planet. Mars, our neighboring planet, has captured the imagination of scientists and explorers for centuries. But why Mars? Why do we strive to make it habitable? Expanding our presence beyond Earth is not just a scientific endeavor, it's a fundamental step for the future of humanity. By colonizing Mars, we ensure the long-term survival of our species and gain a deeper understanding of our place in the universe. But make no mistake, the road to making Mars habitable is filled with challenges and opportunities. From the harsh Martian environment to the monumental engineering feats required, we face a monumental task. As we set our sights on making Mars habitable, we must first understand the harsh reality of the Martian environment. Mars presents us with numerous challenges that we must overcome to create a livable world. One of the major obstacles is Mars's thin atmosphere. Unlike Earth's protective shield, Mars has a much thinner atmosphere consisting mainly of carbon dioxide. This thin atmosphere offers little protection from harmful cosmic rays and solar radiation. Additionally, extreme temperatures pose another hurdle. Mars experiences frigid temperatures that can drop as low as minus 130 degrees Celsius, 202 degrees Fahrenheit, during its long and cold winters. Summers are also chilly, with temperatures averaging around minus 80 degrees Celsius, 112 degrees Fahrenheit. Furthermore, Mars suffers from a scarcity of liquid water. While evidence suggests the presence of frozen water in the polar ice caps and subsurface, the surface remains predominantly dry and arid. These factors collectively make the Martian environment inhospitable for human life as we know it. The lack of a thick atmosphere and extreme temperatures make it challenging to breathe, stay warm, and protect ourselves from the harsh conditions. As we confront these hurdles, we must devise innovative solutions and push the boundaries of science and technology. Join us as we explore the exciting possibilities that will transform Mars into a thriving habitat. First, we have to terraform the planet. Terraforming is the process of transforming a planet to make it more like Earth and hospitable for human life. But how would we go about terraforming Mars? One of the key steps in making Mars habitable is thickening its thin atmosphere. Currently, Mars has an atmosphere that is about 100 times less dense than Earth's atmosphere. To create a warming effect and make the planet more hospitable, we would need to introduce greenhouse gases into the Martian atmosphere. Greenhouse gases, such as carbon dioxide, play a crucial role in trapping heat from the sun. By releasing significant amounts of carbon dioxide or other greenhouse gases into the atmosphere, we could create a greenhouse effect on Mars. This would lead to a gradual increase in temperature, helping to melt the ice caps and release trapped water. A thicker atmosphere on Mars would offer several benefits. Firstly, it would increase the surface pressure, allowing liquid water to exist without instantly boiling away due to the low atmospheric pressure. This would enable the formation of oceans, lakes, and rivers, providing essential resources for future human colonists. Additionally, a thicker atmosphere would provide greater protection from harmful radiation. Mars lacks a magnetic field like Earth's, which shields us from the sun's radiation. With a denser atmosphere, Mars could offer better shielding against cosmic rays and solar radiation so that inhabitants could survive. However, altering the atmosphere of an entire planet is a complex and long-term endeavor. It would require the release of vast amounts of greenhouse gases, potentially sourced from Mars itself or from other celestial bodies. The process would need to be carefully regulated to achieve the desired warming effect without causing unintended consequences. The next step would be to ensure water. Luckily, Mars holds vast reserves of water in the form of ice. The planet's polar caps, composed primarily of water ice, offer a potential source of this precious resource for future Martian colonies. But the polar ice caps on Mars consist of a combination of water ice and carbon dioxide ice, also known as dry ice. One method to access this frozen water is by melting the ice caps as mentioned before. This may be achieved by releasing greenhouse gases, but the dry ice would release a lot of carbon dioxide and we may have to melt the ice first. To achieve this, we may use mirrors positioned on the surface to concentrate sunlight onto the ice caps, effectively raising their temperature and causing the ice to melt. This process, known as sublimation, converts the solid ice directly into water vapor by passing the liquid phase. By capturing and condensing the water vapor, we can collect and store the water for various uses. Utilizing the water ice on Mars is a crucial step in the transformation of the red planet into a sustainable and self-sufficient habitat. By strategically harnessing the power of sunlight and employing innovative technologies, we can unlock the potential of the Martian ice caps, ensuring a steady supply of water for the future of human colonization. The ability to access and utilize these resources will not only support the survival of the Martian population, but also pave the way for further exploration and scientific discovery. Creating a habitable environment on Mars requires a reliable and sustainable source of energy. With limited fossil fuel resources, we must turn to renewable energy sources to meet the energy demands of a thriving Martian colony. Solar power is a key component in our quest for sustainable energy on Mars. The planet receives about half the amount of sunlight that Earth does due to its greater distance from the sun and the dust storms that occasionally obscure the sky. However, even with reduced sunlight, solar panels can still generate significant amounts of energy. By strategically placing solar arrays and utilizing advanced solar technologies, we can maximize the efficiency of solar power on the red planet. In addition to solar power, another promising energy source for Mars is nuclear energy. Compact and highly efficient nuclear reactors can provide a steady supply of electricity, even during Martian nights or dust storms when sunlight is limited. Nuclear power offers the advantage of generating large amounts of energy with relatively small infrastructure requirements. However, stringent safety measures would need to be implemented to ensure the secure operation of nuclear power systems on Mars. Generating renewable energy on Mars does present challenges. The Martian dust storms and the planet's greater distance from the sun compared to Earth makes solar power generation less predictable. However, innovative solutions are being explored to overcome these challenges. For instance, advanced solar panels can be designed to be more efficient under low light conditions, and energy storage technologies can be optimized to store excess energy during periods of high sunlight for use during less favorable conditions. Furthermore, a diverse energy portfolio that combines solar power, nuclear energy, and other emerging technologies can provide a robust and reliable energy infrastructure for a sustainable Martian colony. Research and development efforts continue to refine and improve these energy systems, ensuring their effectiveness in the unique Martian environment. By harnessing renewable energy sources, we can create a self-sufficient and environmentally conscious Mars colony. The adoption of sustainable energy practices not only reduces our dependence on Earth's resources, but also sets a precedent for future space exploration missions and inspires a new era of clean and responsible energy usage. In conclusion, making Mars habitable is a complex and ambitious endeavor that requires a combination of scientific knowledge, technological advancements, and human determination. By following a systematic approach, we can pave the way for the eventual colonization and establishment of a self-sustaining colony on the red planet. So, let us embrace the challenge, push the boundaries of human exploration, and strive towards the goal of establishing a sustainable and thriving colony on Mars. The red planet beckons us, and with each step we take, we bring ourselves closer to a future where humans can proudly call Mars their new home.